Hi, welcome to the Olympiad geometry. Let's continue our study on radical axis. Before we start, if you think this video is helpful, please click the like button, comment, share, or subscribe to the channel. Thank you. Here is a problem. A is a point on the diameter BB prime of circle O. Secant MM prime passes through A. The perpendicular line of BB prime passing through A intersects line BM on N and BM prime on N prime. Prove that AN times AN prime is a constant. So we want to find that AN times AN prime to be a constant, which means that we want to transfer the product to another product. Eventually, that is a constant, right? We cannot directly find AN times AN prime. So for what we have here is that we already know this line, let's call it L. The line L is perpendicular with BB prime. It just reminds us something, right? In the previous videos, I don't remember which one, but I think I demonstrated a concept that once we have something like a line perpendicular with another line, it's usually give us a hint that we want to find the 90 degrees, right? We want to find the 90 degrees so that we can use it for proving or find something like two triangles are similar, something like that. It would be a useful condition, right? So right now we have 90 degree. It's useless if we just keep it there, right? It doesn't matter it's 90 degree or it's 60 degree if we just consider about that the MM prime is a secant and we want to have BM intersects with this line, right? It doesn't matter with this 90 degree. So we want to transfer it. The way we do that is that we can connect M, B prime, right? Now we have a 90 degree here. By marking this 90 degree out, it's obvious that A, B prime, M, N are cyclic. Right? Then we can directly connect B prime N. Because once we have a cyclic quadrilateral, we know a lot of relation between angles, right? And now let's look at what we are looking for. AN times AN prime. AN times AN prime. So this angle, the angle BMA equals to angle BMA equals to angle B prime NA, right? Equals to this angle. And we already know that angle BMA equals to angle BMM prime, right? That's the same angle, and it refers to the chord B prime M prime, which means that angle BMA equals to angle B prime B M prime, right? So it equals to angle B prime B M prime. So it equals to this angle. I think you know what I'm doing here. I'm trying to find as much as possible of the equivalent angles so that we can use these conditions, right? Because this angle equals to this angle, and this is 90 degrees for all of these four angles. So we know that triangle B prime NA is similar to triangle N prime B prime NA, right? So N prime BA, right? And we know that angle NB prime A equals to NB prime A, now this angle equals to this angle, right? Angle B N prime A. This angle equals to this angle, which means N, B, N prime, B prime are cyclic. Right, these 4 points are cyclic because this angle equals to this angle. Then we know that AN times AN prime. See here, because this is cyclic, so let's call the circumcircle of this quadrilateral as circle, circle O prime. Then we know that AN times AN prime is the power of A2 circle O prime, right? And it should equals to BA times AB prime, because BA times AB prime is also the power of A to circle O prime, which means we just find that constant, right? Because A is a point we find it. Once it's a certain point, because circle O is a certain circle, so that the distance of AB and AB prime are constant. That means BA times AB prime is constant. So we find that AN times AN prime is constant. Okay, this problem is not a very difficult one. Just help us remind that once we see this condition, the perpendicular, we definitely need to find another perpendicular or another 90 degree to give us more information, right? I hope you like this video. See you in next one. Thank you.